This video is about a hypothesis test for the parameter M of Poisson. Suppose that the variable x equals number of incidents in n periods follows Poisson distribution. We conduct a test for a parameter M of Poisson. We are given a sample of incidents at n different periods. Sometimes we are given a complete sample of data. Sometimes we are given the total number for n periods. Claim for the parameter M. X follows Poisson distribution with n times M sub O. For HO, M equals M times M sub O. H1 will be M greater than M times MO or M less than N times MO. X statistic equals the summation of the observed frequency. When x greater than m times MO. For H1, m greater than n times MO. Then the p-value equals probability of x greater than or equal to observed frequency. When x statistic less than n times MO, H1 will be m less than n times MO. The p-value equals probability of x less than or equal to x statistic. Conclusion: if p-value less than alpha, reject HO. P-value greater than alpha, fail to reject HO. Just remember, please reject HO. P is a p-value. L means less than. Significance level alpha. Reject HO. Then if we are in favor of the claim, we will write down enough evidence to suggest that claim is true. If we are not in favor of the claim, we will write down not enough evidence to suggest that claim is true. In this test, we will use the definition of p-value to work out p-value. So we assume HO is true. Then we figure out the probability of obtaining the observed result. Let's go to guided practice 1. A city planner is analyzing the number of traffic violations recorded at a busy intersection over 5 consecutive days. The planner assumes that the number of violations per day follows a Poisson distribution. The recorded data is given in this table. At the 5% significance level, test whether the number of violations per day follows a Poisson distribution with mean M equals 6. Keywords here: 5 days, n equals 5, m sub O equals 6. First step, get this observed frequency in 5 days. 5 plus 7 plus 6 plus 4 plus 10 equals 32. Then we will write down HO. M equals 6 times 5 equals 30. H1. Check here, 32 greater than 30. So m greater than 30. Second step, define the variable. Let x be the number of traffic violations in 5 days. Then x follows Poisson distribution, mean 30. Then p-value equals probability of x greater than or equal to 32. Go to 6. Go to 5. Poisson CDF. K. Lambda is 30. Lower bound is 32. Upper bound 4 nines. Enter, enter. Answer is 0.381. Third step, write down the conclusion. Since 0.381 greater than 0.05, fail to reject HO. Check back which one is our claim. This is our claim. Fail to reject HO means the claim is correct. Claim with this check, we will use enough evidence to suggest that the number of violations per day follows a Poisson distribution with the mean m equals 6. Let's go to B. Test whether the number of violations per day follows a Poisson distribution with the mean 8.8. X statistic equals observed frequency 32. HO m equals 8.8 times 5, which is 44. H1. Since observed frequency less than 44. For H1, m less than 44. Second step, X follows Poisson distribution with the mean 44. P-value equals probability of X less than or equal to 32 equals, let's go to calculator. Menu, go to 6, go to 5, go to Poisson CDF K, lambda 44. Lower bound is 0. Upper bound is 32. Enter, enter. P-value equals 0.0365. Then we can draw the conclusion. This is our claim. Since p-value 0.0365 or less than 0.05, reject HO. We are in favor of H1, which means we are not in favor of the claim. We will write down not enough evidence to suggest that the number of violations per day follows a Poisson distribution with the mean 8.8.